Okay, so we'll go ahead and get started just to keep the time frame moving a little bit. They gave us, I don't know, it looks like about an hour, 15 minutes for the presentation today. If you guys are looking to come in and get a nap and just be able to sit still and go through another marketing pitch, hopefully you're going to be sorely disappointed. The way that I tend to do these sessions is a lot more interactive, asking a lot of questions and getting a lot of input from the audience, and try to keep you awake a little bit on your toes that way. In the past, I've had little bouncy balls or stuff we could throw as part of that, but kind of dark in here and hit somebody in the head, so I guess we'll have to wait and let you come by the booth and get some of that kind of stuff here in a little bit. For those, how many of you in the room have had a chance to come by and see the Nutanix booth in the back corner where we're set up near the food? If you don't know where it is, feel free to come by. If you have some deeper questions that we haven't been able to tackle in here, we'll be happy to do that with you there. Some of you might have had a chance to fill one of these forms out already there. We'll give you an extra bonus if you have already done that there, and give you a chance to do it twice. Because you came to the session, you can fill another one out here and increase your chances to win by just a little incremental piece at the top. Okay? And so we'll go with that just a little bit, just again as an extra thanks for being here today. So how many of you had heard about Nutanix before you came to BriForum this year? Okay? We've got a few people in the room that are actually customers, and a lot of times the presentations that I give are more in a user group type setting or users helping users, and that's where having the interactive conversation really helps a lot as well, because somebody will ask a question and I can point to somebody else that's already doing it and ask them, well, how did that work out? You know, is it just some guy up here talking, you know, that's making stuff up, or is that the reality that you experienced in your environment? And we'll go through that a little bit as well today. For those of you who have seen Nutanix before you got here today, what is it about the solution that if somebody says, well, tell me about Nutanix, what is it? Can somebody just take a stab at maybe 20 seconds of what is Nutanix to you based off of what your current understanding is? Anybody? It's an icebreaker. It's an easy one, a softball. Nutanix is, I don't know, something new that's hard to say. What did we do? We cut the cost of VDI. That's cutting to the chase, okay? We're making the business case for VDI actually workable. That's a very good, strong use case on the desktop side, and then, of course, it's there on the server side as well. Okay, so that's a really good one-liner. What's another one, that you would describe it to somebody? Start calling on people. Roger, how would you say if somebody's never heard of Nutanix, what is it? Okay. You get everything in one box. All right. And so we'll talk about some use cases where that really fits. And Rogers is a pretty good use case from that perspective as well. And we'll talk through some of why that's very compelling from that scale-out architecture and how they're doing that. But I'm going to walk you through that. I just wanted to kind of give that one to start with. Some more general ones. How many of you, this is your first BriForum to come to? Nice, easy question. How many of you have been here before? Sometimes it's useful to look around the room just to be able to see some of these questions as well. How many of you have been doing VDI of some form? They hate it when I say VDI. Desktop virtualization, application virtualization, things that you're using to help your end users related to virtualization in particular, for more than 3 years. Okay? You see how much of the room that's starting to become? How many of you are not doing any desktop virtualization type projects so far? Okay? You see how that's dropped off tremendously year over year? Okay? How many of you are still in a pilot phase in your mind to where you still haven't started rolling it out seriously across your enterprise? You'll see a few more, right? But the point that I'm making is it's getting a tremendous amount of traction, where in the past it's always been people wanting to do something. They'll play with it a little bit, and then they get kind of hung up. Okay? For those of you who have been doing it for a while, or even some of you that are in pilots, somebody holler out what are some of the challenges of why you're not doing more of your desktops or even all of your desktops today. Cost per desktop. Cost per desktop. Never hear it. What else? That's a good point. Anybody else? Apps. Okay, what apps can be virtualized? What challenges there are as you virtualize them? What are some other issues? Scale up problems. What do you mean when you say that? There's some particular pieces, right? Like what?
200 users is a lot less complicated than 2,000.
Okay. How many of you are doing more than 200 virtual desktops today? How many of you found it to be fun? Okay. And so once you learn how it can be fun, okay? But the getting there is a little bit more challenging, and it's a very good point and something that we see. We either call it a wall or a cliff, depending on how adventurous you are, what you hit when you get to sometimes 100, sometimes 200 desktops, and what you have to do to re-architect to be able to do that, right? How many of you are doing 100% server virtualization? 100% of your server workloads you've got virtualized now. Look around the room, guys. There are some. How many of you feel like you're more than 80% virtualized now? A whole lot more, right? Why are you not more of you between the 80 and the 100? What challenges are you still seeing from being able to get to that, next tier, if you will? Okay, stupid ISVs. What was the other? Dongles is another really good one where you still have some hardware dependencies. AIX. Still got Unix. I can't get rid of the last ones. Which is really funny because when I was a Unix admin, we were saying that about the mainframe, and it's really nice to be able to see that shift down into more of the commodity hardware at the price point as we're rebuilding the mainframe, right? In the virtualization space. What are some other challenges with server virtualization as a whole that makes it a challenge to be able to get those last applications, those last servers virtualized? I/O? Resistant developers. Okay. How about some of the major high-performance applications that are still, working better on physical hardware? Anybody still think they got any of those? Not as much anymore, right? Because vSphere 5 and some of the other stuff are raising the bar on what you're able to do there. But you know what happens today if you call Microsoft and says, look, I really want to Exchange and SQL to be virtualized or be able to do this better. I'm definitely doing it on virtual. What do you think they still tell you to do to get the performance out of the box? Who's talked to them lately? What do they tell you? Go physical. They'll let you do it virtual, but there's one thing in particular that they're really pushing hard for, and they've been doing it for about 18 months now. Direct attached disk, right? They say, I still want you to do it, even if you virtualize it, make sure you do this with direct attached disk. Why? I/O, right? I can guarantee the I/O to the application a lot better if it's totally within my local span of control there. I'm not going over a SAN. I'm not doing a lot of the pieces. And frankly, you can make it work just fine over a SAN at high I/O. But there's a reason Microsoft says that, and that's the troubleshooting, the different organizational units between the teams and that kind of stuff become more of a challenge to do performance tuning, corrections, best practice kind of stuff. If they come up with a best practice that says you have to set it just this way and then you'll be much better with your performance, and the SAN team goes, we don't do that. That's not the same settings that we have on these other areas, that kind of stuff, right? Anybody else run across that? How many of you in the room is the same team that does the servers and the storage? Okay, if you look around, you're seeing about half the room. How many of you, just to show the other side, it's separate teams that do your SAN and your storage? How many of you would say that you have a really good relationship between the server team and the storage team in your organization? Look around the room, guys. Why is that? You're both IT, right? You're both pulling the same harness at the same time in the same direction for the benefit of your users, the business, right? You're same guy to them. It's IT. But when you see that, that's a 90% pervasive argument, okay? I had two guys in the room that raised their hand when they said they got a really good relationship between their server team and their storage team. Why is that, guys? Give me some examples of why that's still a case for what you're talking about today. Anybody? The answers that I usually hear fall along the lines of standardization. We do it a certain way, they want to do it a certain way. Sometimes they don't work well together. Sometimes it's just a handoffs. Sometimes it's a difference in the training, right? The guys go off to school to learn about their legacy storage vendor. These guys go off to learn about virtualization and the other stuff. And the things that they're told or learn might be different. They might be even counterintuitive or contradicting each other in what those presentations are, right? Somebody throw it out and says, no, I don't agree. I don't have those types of issues here, right? You look around the room, I'm seeing a lot of guys nodding their heads and saying, yep, that's similar to what we're running into, right? And the point that I'm making there is it's not unique. You get a room with 100 people in it, 50 people in it like you have today, and you start to see some similarities begin to emerge, right? Okay, I want to back up and kind of say some of the pieces that we've talked about just in the interactive part that kind of builds into what we're saying isn't just us saying it up here. It's you guys saying it over and over again in the room. They're saying, hey guys, 10 years now. We started with ESX 10 years ago. I've got the 1.0 manual sometimes I bring and wave around of ESX. And before that, it was GSX and Workstation, and the other stuff were the really bleeding edge. But it was 2001 when I really started looking at, 2002, and in 2003 when I made a major purchase of like 450 sockets of licensing for ESX, okay? Which was a little early for a major enterprise, but it was something that was already proving itself that it was going to be transformative to the data center. Everybody laughed when they heard it then, right? And so this is something that's really going to make an impact because it's already apparent, even though the manageability is kind of weak, even though you don't have things like vMotion to start with, or even Virtual Center in the early days, made it really challenging to be able to manage, but you could already tell in those early days that virtualization was going to be transformative. It was going to be something that we were going to look back on in 5 years, in 10 years, and say, yep, saw that one coming, right? Because the cost savings, the opportunity was tremendous, right? I could run 5 servers. I could run 3 servers at the time on DL380 G2s. It's nice seeing HP out here with their G8s, is it, that they're showing now. But moving off of G2s, fixing to move into G3 hardware, and I could move from having 3 to about 6 VMs on each server. And that was pretty amazing because that was a heck of a lot less stuff I had to do from a capital expenditure side, right? But if it's so wonderful, if 10 years later there's not anybody in the room that says that there's not any workloads in their environment that aren't appropriate for virtualization, right, that they don't feel like the horsepower is there, then why are people not more virtualized both on the server side and on the desktop side? You saw the room. Nobody in here, anybody in here virtualizing 100% of their desktops today? 1, okay? It's always fun to look around, okay? Why are more people not doing that? And you heard a lot of the same answers. So cost per desktop was called out. Cost of storage in general is becoming much more of a visible line item on IT budgets. I'm seeing the heads nod, right? As I do more server consolidation, my storage consolidation is going great too. I can get 10 gigabytes in the same 1 gig. Well, yeah, with some dedupe and some thin provisioning kind of stuff I can, right? But in reality, the data is exploding and getting much bigger relative to the number of servers or instances, that kind of stuff that are going into the data center. And consequently, the storage price point, particularly on a IT budget, is becoming much more visible, right? And so you can see that storage affecting, we're at a desktop virtualization or desktop focused type of a conference this week. And so you see that tremendously in VDI because it's very visible as you start dividing out what that price per desktop becomes, right? So I'm not telling you anything new there. The second one is on the complexity side. How many of you have found that as you have moved towards virtual desktops, it is less complex than the way you used to manage it with separate physical desktops? Okay, I've got a hand. How many of you have found it to be much more complicated than you ever thought it was going to be when you started down this path? Why? What's different about it?
The boxes are running on a single device so that when you're doing something to one box you're affecting, you can't affect many.
He says that because you have so many desktops running on a single server, when you make a change to one server, it can affect a lot of desktops, which is exactly the opposite of what made it less complex in the old environment where everything was running on one box. And if I swapped out that thing for one user, I was affecting, and it was more in my management domain and more in my even failure domain. It's only going to affect a single person. And so usually the answer that we hear back very quickly is that in the past I had a desktop team that when they finally got the budget approved to be able to go and replace desktops, they had to talk to nobody or their edge networking team, and that's it. They could go and do what they needed to do. Who do they need to talk to now? Everybody, right? My data center, space, power, cooling, networking, storage, desktop, ESX, or Zen, hypervisor team of some sort. All these different people have to be coordinated on the same page, appropriately trained, and then have some burn-in time, to be able to get it right, which, might be a pilot that could be 9 months long to make sure they can do it right before they roll it. That's a whole lot different than what I used to do with desktops, right? And so the complexity, the provisioning, even just on after you get it installed, what's different, right? Just doing the normal tasks of setting up a new user, mentioned just hiring Joe, just getting Joe set up to include his virtual desktop and his phone and the other stuff, the challenges have changed quite a bit. I used to say, yep, go grab another PC off the stack, plug it in where he is, provision a port, you're done. Now what have I got to do? I've got, as I'm moving in new teams, doing different types of pieces, provisioning storage, deploying tiered storage solutions, completing backups on time are all major challenges because all of those things changed in how I was doing them. Some of them bring operational efficiencies. I finally can back up what those people were storing on their desktops because I can make them store it in stuff that's getting stored in the data center now, right? So some of the stuff you can actually help them with, but the process for going through these things are different. I had in my environment at a Fortune 75 size company before I moved over to the vendor side about 3,500 servers. And then we were going through the process of virtualizing the server side and got about 50%, 60% done pretty quick, early adoption, test dev, work your way up through low-end production and start working your way across those critical production ones. And so you got up to about 2,000, 2,500 images, right? And it was a challenge to manage that with, 10 people, 12 people, because you were still doing a lot of evangelism of the technology and a lot of the other stuff, testing new hardware, testing new software, new revs of VMware, whatever it was. But you had this ongoing process that was cumbersome and difficult to manage for 2,500 VMs. Then we came along and said, let's consider doing VDI. And it's kind of interesting to watch people just start having little seizures or technical fits, because what they realize very quickly, and that's not meant to be ugly for anybody that actually has or knows anybody with serious physical disorders that way, but that's what it looks like when they're sitting there at the table with you, because what they realize you're telling them is, I'm going to take you from what could be 3,000 servers to 30,000 desktops like that. And what do you feel the comfort level is with your management tools, your uptime, your weekends, your nights, your cases that you're having to take on from a support perspective as you move 10x with the same generation or the same instances of the technology? And that's where people really start falling off the wagon. The complexity at scale is a whole lot different as you start down that path. And not only that, but you've got a lot more end users that are very visibly seeing what that end user experience is like as you go down that path. The third one you mentioned has to do with performance. And so as more people go down this path, they start seeing a lot more challenges that they didn't even dream of when they were doing the pilot, because when I did my little IT staff of 8 guys or 10 guys, it went very well on the hardware that I was running at the time. But then when I started rolling it out, okay guys, we're golden now, we can start doing this in mass. Once I pass that 100 or 200 desktops, again, I really start seeing a lot of major performance walls that I start running into. Typically related to I/O, latency, performance, other types of stuff that you see that come up related to that, right? And that's not just with desktops, you see that on the server side as well. And it particularly comes up when I start looking at environments and saying, let's see how dense you're running your current environment. How many of you know, with, because you've been looking at it, what percentage you're using your hosts from CPU and memory today? Are you at, show of hands, 80% that you see utilized in your environments? Anybody? Look around the room, guys. Higher than 80%? Nobody, right? How about 70% utilized? 60% utilized. You're starting to see the first 2 hands, okay? 50%. 40%, and you start going down that curve, and what you see is exactly what we're trying to show there, is the way that people have found to be able to effectively manage their environment has a lot to do with overcapacity. I got my nights and weekends back. I can finally go to the kids' play, but it's because I'm running my infrastructure at no busier than 50% utilization. Wow. Okay, so you're still saving a lot of money because virtualization is helping, but that cost per desktop of what you put in that business plan just went out the window because you were basing it off of a much higher utilization percentage of what you were going to be able to use for CPU and memory in those boxes. Does that make sense? Y'all see what we're talking about there? And so what we tried to do over the last 4 years, say in the last place that I worked, was focus on virtualization management tools and be able to do things that improve that operational efficiency, if you will, and do more automation and stuff to where you don't have to have as much intelligence in the staff to be able to manage it, put it in the tools to where you're working towards more self-healing. And that's proceeding a little bit, but not nearly as fast as it could be. And so what's the answer then? What we've seen in the recent generations of hardware is an explosion in the amount of cores and memory that you're able to throw at a problem, okay? So if I use those DL380s, again, if you go to the Nutanix booth, they're set up right across from us. You can see the new hardware that they have there. We were excited to have dual core. Going to quad core, that was pretty exciting. Now they're up to 10 cores, or 8 cores in a lot of the servers that you're seeing out there per socket. So I don't see as many people buying 4-socket servers anymore. They're going with the 2 sockets as a really nice sweet spot in the marketplace. And they're doing 6 or 8 cores on each of those and getting, that kind of density, 10 to 12 cores per, or a few more. What would that be? 16 cores on the 8-core systems, right? And that's a whole lot more than you would have thought, even just a few years ago. And the same thing's happening on memory. How much memory are you guys putting in your servers today? Somebody throw out a number. I don't know. 92, 256, right? So depending on what technology you're adopting, a lot of people are really looking forward to what Sandy Bridge is bringing, where I'm able to go to 512 fairly easily in a 2-socket server, 512 gigabytes of memory. Okay? And I can do that with, what are the choices now? I can do 8 gig DIMMs, 16 gig DIMMs, and now they got these 32 gig DIMMs. If you've seen the pricing on those, it makes it kind of entertaining to be able to focus in this area, right? And so what you find is people trying to map to that sweet spot in the marketplace of what's the right fit for cost and performance to be able to help me balance across these, and what things can I do in these areas to be able to make things better. Okay? So I intentionally try as hard as I can not to make it a marketing pitch. Let me just jump in and tell you what we're doing. But instead, let you guys tell us what you're needing from these particular areas, and be able to show you what we're talking about, and saying, how about if you had a solution that addressed those 3 main points, and really making it very effective for both server virtualization and for desktop virtualization. These 3 things would be of keen interest to every one of you in the room. If I could do things at a better managed cost, be able to do it at a much less complex method of doing that, and be able to simplify the interactions between the teams, and be able to make things actually doable in a very quick time frame, and then have the performance there to be able to back it up, those would be very useful based off of all the input that you've given us so far. And that's what we're talking about that Nutanix is delivering, and what we've brought to the table in our current shipping products. These aren't futures. These aren't things that we're hoping to get to. These are things that we've been shipping for a year now, and have been making a tremendous impact in the marketplace because of it. Okay, so just a history piece, network storage was designed for physical servers, right? It did a huge amount of wonderful things there, allowed you to add have a big pool of storage and carve it up between different servers. Nothing new there. Anybody know when we started doing things this way for x86 servers? It's been 12 years now. We've been doing it this way for quite a while, with the same type of architecture, where I have a separate architecture for servers, and then storage, and then some type of a storage network that's connecting them together. It wasn't designed that way for virtual machines. We're using shared storage so that we can have some of the nice-to-haves with virtualization, right? Being able to move workloads around with vMotion, for example, or to tolerate failure with HA, high availability type of events that go on. When a server dies, I'd like for those workloads to be able to start on another host somewhere else in the environment, and be able to do that. But there's challenges that come in because it wasn't designed for virtual machines, around the complexity that changes, the performance, the scalability. You got data that moves around a lot, or workloads that move around a lot, and you've got challenges that come into that. And then, of course, cost comes into the equation as well. So to me, this isn't news. This is stuff that you guys have been living with for quite a number of years now. And it's just something that we're watching to see over the last 4 or 5 years, how have people been making changes to address that, okay? And so I'm going to shift over and actually show you a brief little video clip that walks you through a little bit. It's like Nutanix in 90 seconds, if you will, and it will help to make that case a little bit more of what's going on, and then we'll tie it together with what we've been talking about so far as we continue in what we're talking about.
Meet Greg. Greg spearheaded his company's virtualization initiative and consolidated 100 servers down to 10. But what he didn't account for was the headache of managing the capacity and performance of his SAN, as more and more virtual machines machines were created. His SAN is super demanding and sucks up all his time, like a bad relationship, leaving him no time to do the stuff he wants. It's also draining his IT budget as he tries to scale to support his company's demands and still meet performance expectations. And now his CIO wants to do virtual desktops too. Greg realizes it's time to call for help. Greg calls up Jack, an even bigger IT whiz than him. Greg finds out that Jack isn't wasting his time with storage appliances. Jack knows that these are expensive and don't fix the real problem. Instead, Jack has been paying attention to what the big cloud guys are doing in their data centers. Jack tells Greg that the only way to get real scalability and performance is to bring compute and storage together into one tier. But Greg questions if this solution is for him since he is doing virtualization, not running a search engine. Jack strikes down Greg's worries and informs him that the guy who designed Google's distributed system got together with some crazy smart engineers to start a new company, Nutanix. And they built a distributed compute and storage system designed for virtualization. Jack got it up and running in his data center under 30 minutes. And better yet, it's blazing fast because the storage is all local, but things like vMotion and high availability still work seamlessly. It's like magic. Greg now knows what he must do. It's time to dump his SAN and start living the Nutanix way. Nutanix.com.
Okay, so that kind of gives the overview, like I said, in just a 90-second clip of what it is that we're doing and how we're going about tackling some of these challenges that we've been talking about, right? And so, turned it off. Let's see here. So being able to look at what some of these other providers have been doing as they've had to tackle the same problems, okay? So you think you've got challenges at the scale of your infrastructure. We were talking a while ago about some of the size. How many of you have more than 50 ESX hosts in your environment today, or virtual hosts, whether they're another provider as well, okay? You're starting to see that number get to be much larger, right? But these guys, obviously, they're not doing virtualization, but they have the same scale-out type of challenge. And you want to think about what the pains are that they're going through. We talked about cost being a primary concern in our data centers of what we're going through already, right? Imagine what it is with hundreds and thousands of nodes that get added on a very regular basis that these guys are going through, right? And so what have they done to be able to address what those cost challenges are and some of the other stuff, right? So if we take a look at what some of these major players have been doing, who knows some of the ways that they've been tackling that? What have they done to manage their costs, for example? Do you know? How much have you followed what these guys have been doing over the last 3 or 4 or 5 years? How about they're buying really cheap servers? Anybody had a chance to see a Google data center? Yeah, so really, really cheap stuff, okay? They're saying, I'm tired of paying a premium for commodity-based hardware, whether it's on the server side or the storage side. I want and I need to get back to a commodity type of a platform that I can be able to use to do that. And so we've got some of those Google data centers like in Atlanta where I'm based out of. And then, of course, they're spread throughout the country. If you ever get a chance to go see one, like if you're in a colo, you say, hey, you got any Google stuff here? A lot of times you can see what that stuff looks like. A lot of it doesn't even have sides on the servers. You're looking, oh, there's a processor board. There's, you can see right through what they're doing where they're really managing that cost. And if you ever see what their little hands and feet guys are doing when they come in to fix broken servers, that's kind of telling too. What's that? They throw them away. They walk in there. It's not even worth their time to go into the data center until I've got 10 of them dead in a rack. Why? What gives them that kind of fault tolerance? Do you know? Okay, the applications are more, there's one more piece that really does it for them. It's the fault tolerance that they've built into that infrastructure in their distributed file system that they're using that makes that stuff available, okay? And it's not something that they got from that commodity provider. It's stuff that they're having to do on top of it. So once they get 10 of them that die, they come in there with a little cart, and they just yank out 10 of them, and they throw them in the trash, and they put 10 more new ones. They didn't even take a time to figure out whether the CPU or the memory can rescue some parts of it, because they've learned that the time that they spend on that kind of stuff and even just maintaining the stock is actually more expensive than what the server costs. Okay? And you see that some in your desktop justification that you guys are doing now. Okay? One of the primary justifications that we see used over and over, particularly if you have remote sites for doing VDI in the first place, has to do with the time and the cost it takes for a remote technical guy to go and do that work. Our price point was something like $200 or $225 per desktop. Every visit was what they were calculating as the cost to go and do that fix, because they were spending 45 minutes to do the troubleshooting, or have to get the parts and visit twice to do the replacement after they figured out what was dead. All those different pieces added up, and I was only paying $400 a desktop. Right? And so that's what the difference was, and that was several years ago. But the point that I'm making there is you can see what Google's going through here, of why they say it's more cost effective for them not to do the troubleshooting and just do the replacement if I can get a sufficiently cheap enough commodity hardware in their case. Okay? So that's just using Google as an example. These other guys, if you're reading Facebook here lately, of what they're doing in their data center, it's just astronomical, the kind of scale for the number of pictures we keep posting on that thing with the kids on their tricycles and stuff, right? So it's amazing the growth that they're having to go through to be able to do that. And so they've really been focused on how can I be more effective at managing cost. And so it's not meant to pick on particular vendors, but they were specifically saying I can't keep paying big checks to my legacy hardware providers at their premium for the features that they have, because frankly I don't need those features. And I don't need to pay that premium. I want to get back to doing things with local attached disk, with commodity hardware, and be able to manage that cost. So that's why they were going down this path. But they said very early, even when they're doing their proof of concept with it, there's certain pieces that I'm going to be leaving on the table if I'm not careful. I've still got to be able to figure out how I'm going to manage how to do that at scale, to add a bunch of them fast and have the system help as much as it can to grow. I need to have that performance. And when I go with single, less expensive type hardware, then I'm giving something up. I can pay a premium, double, triple the price sometimes, and have the latest, fastest processors with the most cores, that kind of stuff, but I'm going to be paying more for it. So I need to make sure I'm addressing that performance and making sure I have fast access to that data, and that I'm not limited by network bottlenecks as I'm trying to roll out this type of solution. And oh, by the way, I can't have one admin per 40 servers. I can't even have one admin sometimes per 400 servers with some of these guys. And so I need to be able to have it manageably, easily at any scale. And so all of these guys, it's funny to watch them. Some of them started earlier than others, and then some have been later, but they've all reached the same conclusions. Okay? So they've all come up with, okay, I want to buy commodity hardware. I got to be able to manage it, and I want to be able to make it where I can make that part function. And of course the question comes up is, how did they do that? What are some of the pieces that they were really able to do different to be able to do it? And you guys have already answered it, which is why I almost skipped over it, is that they're doing it without having a storage network in between at all, right? They're doing direct attached storage, but they're doing it in a way that gives them that fault tolerance and that distributed file system across it. So I'll use this one just as an example. This is something Google did early on, where they started with having their servers separate from their storage, but they said I can do a lot cheaper storage by doing x86 servers there with the direct attached disk, but I'm just going to call them storage servers, and I'm going to stripe across it some new intellectual property that that they developed at Google called the Google File System, that was doing that distributed file system at very significant scale. Okay, so non-blocking architecture, a lot of the major innovations in the back end to be able to do millions of tasks in a scheduled time period, things of that nature, as they scale to hundreds and thousands of servers. But then this little guy, even on an IP network, began to be more and more challenging for them because of the cost and because of the complexity as they continued to scale. And he said, I got to do something about that. So you guys already know what they did. They went and put the storage on the same nodes as their compute, right? And once they had it there in the same place, then they were able to have that locality of data, that performance that comes from having that direct attached disk that Microsoft is still recommending people do for those critical workloads. And they're able to do it on that commodity platform where they're able to drive the cost down. And then they have this Google file system that they had developed for their applications, for using their APIs for their workloads, to be able to provide these things. The scalability that needs to grow as you go, the performance that's needed for their modern applications at the time, the fault tolerance that's needed for high availability, and of course the simplicity to manage that as they continued to grow. Why am I spending time talking about what Google's done? You heard it on the video, right? The founders, actually the lead architect and the primary developer that developed this Google file system, is actually one of our founders. He said, this stuff that we solved there a few years ago at Google has a huge opportunity in this enterprise marketplace in virtualization, because we've got exactly the same problems. What we put on the slide a while ago around cost, complexity, and performance are exactly these same things that they had been tackling at Google. And so he came over with some new business partners and started a new company, called it Nutanix, and said, we're going to solve this same problem of how to do this distributed file system and be able to help to manage that cost the same way that we've done in other places. We're going to manage that complexity in a much different fashion, and we're going to be able to deliver that performance to be able to solve a lot of these same challenges, okay? And so that's what we're doing, and the architecture looks remarkably similar to what was being done at Google in a lot of the back-end stuff. But people ask me all the time, oh, so you're saying you use GFS in your solution? Our answer is no, GFS isn't used anywhere that I know of other than at Google, because it uses specific APIs that were written for specific applications, docs, mail, maps, all the stuff that they're doing there. What we've done is had the same guys, especially on the lead developer, that came over and said, I want to start with a blank piece of paper, and if I was doing this again based off of everything that we've learned, and would like to have done a little bit differently at Google even, improvements to say, if I was doing it again from a blank piece of paper, what would I do for enterprise virtualization? And that's what they've done, okay? And so they call it the Nutanix distributed file system, and it's leveraging things like NFS to be able to provide that at tremendous scale, and we'll talk some more about that as we go through, to be able to solve a lot of those same problems that you guys were highlighting, okay? And so that's what you saw in the video if we were highlighting what those things were, right? So you saw that, combining the compute and storage together, drawing from the strengths of what those major players are doing, specifically, one of the primary guys that came over from Google that started this company. It's not a Google subsidiary or anything. It's something they left and started completely from scratch, and have done here to be able to solve that same problem. And why is that something that's relevant based off of what we're talking about here? It's exactly what you see here on the screen, and more of you would be seeing it if we were running at more than 50% utilized in our data centers, but we've been able to mask this for a period of time because we've over-provisioned. We've intentionally built out more capacity than we've required, and so we've been able to limp by, if you will, but it's starting to catch up with us. And what's happening is you're seeing in people that are running their data center more at capacity, and as they're running more of the denser workloads, things of that nature, you're really starting to see more of the bottleneck that's developing in this legacy infrastructure, particularly in the storage network. As these servers get more capable, more cores, more memory, more desktops, more servers that you're cramming onto each one of these. A lot of people are now above 30 servers in each one. 45 is also being done in a lot of the newer generations of hardware on the server side. And in desktops, of 100, some of them are over that. How many of you are running more than 100 desktops on some of your servers today? Okay? How many of you are running more than 75 on some of your servers today? How many of you are running more than 50 on some of your servers today? How many of you are tired of raising your hand? Okay, so what we're looking at here is you're starting to see more of this stuff that's going on as people do more of these dense workloads. So the servers are getting stronger. The storage is getting stronger. They've been telling you for the last few years, oh yeah, don't worry about the storage. You can get the performance. You just have to what? Put what in the storage to be able to get the performance that you need. Okay, solid state drives, right? I can get you better performance if you'll just spend a little more, a little more, a lot more, right? And especially if you're trying to maintain similar capacities. Okay, so in the past I had X number of spindle drives giving me X number of capacity. Now in order to do the same thing with solid state, I need many more drives because they're smaller typically, and they're more expensive for the same amount of gigabytes of space, right? No, Brad, I don't know what you're talking about. We don't run into that. We got really good discounts with our vendors. So that's what you're running into as you get better performance down here. And that's what we're talking about here with this putting these SSDs in down here. But I'm intentionally calling it the SSD Band-Aid. Why am I calling it that? It's just buying you some time. You're still going to have the same challenges here and here. What are you doing on the server side now? If you were doing SSD on the storage, okay, I did SSD on the storage side, and I'm still not happy with the performance, Mr. Vendor. What else can I do to be able to boost the performance? What do they tell you to put in the servers now? What do you call it? Flash what? NAND flash. Okay, if you'll put flash caching or flash memory of some sort on the server side, I can get you a little bit farther. So now I've got super performance on the servers, and I've got super performance on the storage, and I've got the same stuff in the middle. Well, how's that going to get better? Well, I can tell you how it's gotten better in the past. I had 2 gig fiber. They told me go get 4. I had 4 gig fiber, and then I upgraded my infrastructure, and they said, it's not good enough anymore. Go get 8. Now I'm at 8, and I'm tired of replacing this stuff every time something comes along the pipe. Same thing on the Ethernet side, right? I did 1, now I'm at 10, and what are they telling me now? Yeah, that'll work for now, but you need to start planning for 40 gig. Great. I'm tired of ripping and replacing this every time I do something here or here just to be able to keep that piece going. Please tell me there's something coming that I can do about that, right? And what's coming? And so if you go and ask any of your vendors, the one that you said, hey, what do I need to do? And they said, go buy SSD, and thank you. And now go buy NAND flash, thank you. Now what are they telling you to do? What are they telling you is on their marketing plan for what they're going to be coming out with? We're going to be doing the same thing Nutanix is. We're getting there pretty quick. We're just not there yet. We're going to remove this middle tier completely and put the storage up on the same servers, just like Google was doing earlier, right? And we're going to put that together to where you have a shorter path between the compute and the storage. Somebody throw out, what are they telling you how to do that today? They said, yeah, we've already got it working for some stuff. You can buy it today. Just take some of your most critical VMs and put them into your storage array, because they happen to be running Intel processors now, and we're going to be able to do that, right? And so you see this coming, and if you go have a conversation, especially on architecture, with any of the legacy vendors that have any type of market share, they're all going to tell you the same thing. They're pedaling there as fast as they can get there because they know this is where the market is going. Okay? And they already have solutions at small scale that they're going to be able to tell you that they can do that with. And it's stuff that we were looking at more than 2 years ago, almost 3 years ago, saying, I know that's where the market's going. Let's go ahead and get started on it. And we've been shipping product doing that for more than a year. Okay, so that's what you're looking at here, is running your VMs, your desktops on the same host as that direct attached storage, but then we're taking that and layering on top of it the Nutanix distributed file system that's being able to give you that fault tolerance, the scalability, the ease of management that I'm fixing to show you in more detail. It's not storage, but it's rather a virtualization appliance that we've built, this Nutanix converged virtualization appliance. What you're buying when it shows up from us, I'll show you a picture of it here in just a second, is actually 4 ESX hosts and its storage in the same 2U box, same size as a DL380 we've been talking about the whole way through. And it's already pre-built for virtualization. It'll actually come pre-shipped with ESX5 already on it, and then you just put your IP addresses on it and your licenses over time. It comes with 60-day eval licenses, and then you're up and running, and then you can take it from there and put whatever, XenApp, XenDesktop, View, your regular server workloads, whatever on it. And yes, before you ask, it's also leaning towards becoming multi-hypervisor, that we're not doing anything with VMware that's specific to VMware. They've got all the market right now, and so that's what we've been focusing on for this amount of time. But as Hyper-V gets more traction, as KVM and Citrix get more market share, we've already got it running in the labs on it, and we'll be focusing more time and attention on performance and QA and all the regression tests that have to be now multi-hypervisor that we've been avoiding for a while. Okay, so it's not just storage, but think server attached Fusion I/O, which we haven't mentioned yet, and we'll go into in a lot more detail, and traditional storage delivering true, didn't see that one in there, but true legacy type of storage experience for local VMs, okay? And so we'll show you more of what we're talking about there as we go through. And that one says one vendor. You'll hear me mention some others as we go through. Okay? So what we're talking about here is showing you what the hardware actually looks like. What is it that we're talking about if we were to actually look at the physical hardware? What we're actually bringing to the table is more that distributed file system than anything else. But let's talk about that commodity hardware for a minute. If you go to our booth, what is it we're going to be talking about today? What does the hardware look like? Even though we told you it's commodity hardware, and you can actually get it from about 10 different places. Don't guess clicking on this thing is going to help me. And so what you're looking at is a 2U appliance, same size and shape as, say, a DL380, a 2U form factor. But again, it's purpose-built for virtualization. It already comes pre-built with a lot of this to be able to get things up and running faster. Okay? So what you're looking at on a dark screen up there is 2 processors, which are hexa-core processors today on each one of these. So 4 ESX hosts inside that 2U box that you just saw. Think of them like half-height blades, if you will. So you've got 12 cores per server or 48 cores per 2U box. You've got 48 gigs of memory that comes standard, which is fine for certain server workloads, things of that nature that aren't as memory intensive. But for VDI and other use cases, we expand to either 96 with 8 gig DIMMs or 192 gigs with 16 gig DIMMs. in each node. So that means you can have up to 768 gigs of memory in a 2U form factor, and then it scales out from there, and we'll go into that in a lot more detail. Next, you have this Fusion I/O card that's present on every single server in the environment, and that's what's giving you a tremendous bump in performance, and is also responsible for a fair amount of the price tag because it's not cheap. But what it has in it is being used for caching, for every write that's hitting the system, and it's also the primary disk tier for all of the reads and writes. So if you guys are familiar with tiered disk, where you're writing to a faster tier, and then as it ages out because it's not being used, or different I/O requirements, it will destage that to the spindle tier. I say in the back end because that's the way the slide is, but it's actually the front of the box. But it's moving off of that fast tier to the slower tier that's there specifically to lower the cost of the solution, okay? And so you can buy all flash, okay? You mentioned that's what they're saying, go buy NAND flash. We just were here in Chicago, actually I think here in McCormick Place, doing a storage decision show a few weeks ago. And it was very entertaining to see. Every vendor there was pushing flash. And they were pushing flash in 1U boxes and 2U boxes that were storage only, that were $200,000 and $300,000 a box. Okay? And you were getting tremendous performance from that. It was awesome. But it was all flash, single tier. And if you put, say, your desktops in there, they'd run very well, but the static data that's not being used 90% of the time is on that same expensive storage that the active data is. What we subscribe to and what we're doing in our box is actually a tiered disk system that says put the stuff that's active, that needs that high random I/O particularly, on that Fusion I/O card, and move that other 90% that are never touching on those C drives, all those DLLs, everything about that image that's not getting used, move those blocks back to that less expensive storage. And so we're actually using SATA storage on the back end to be able to do that. Okay? People ask me all the time, hey, can I get SAS? Can I get SATA SSD back there? And let's talk about that for a minute. We actually do have a SATA SSD on each node that's being used to boot ESX, to boot our storage controller VM. We actually have a storage processor VM that's on each ESX host in the system that's actually managing that local storage in that Fusion I/O and presenting it as distributed storage back to the hypervisor. And so it runs on SSD. We do that because vSphere in particular also has the capability of really enhancing performance by having the swap files for those VMs in a local SSD that's running on the same server that the hypervisor is running on. So you have an SSD on there, and so we could, for certain use cases, it's kind of interesting. I'll walk you through in a minute. We can put those SSDs across the whole back end, but it raises the price a lot. It lowers the capacity a lot. If you're paying attention, that's a 300 gig drive. The others were terabyte drives. You just took away 2/3 of my capacity for something that's not really going to help performance for most people, because I'm already getting the performance to my guests from that primary disk tier of Fusion I/O. That Fusion I/O running at PCI speeds is actually faster than what I'm doing on this SATA SSD that's going through an ATA controller, right? And so I'm getting the primary tier and getting the performance based off of that, and then I'm destaging it back to that secondary tier for balanced cost and performance. So again, taking that page out of the Google book, saying I want to lower the cost at the right balance point for performance to be able to do what I can on both of those pieces. The other piece that you'll see us balancing that cost for now is on the networking side. What we're doing is we have a 10 gig port that's on each node, say here, on each one, that is actually going to a top-of-rack 10 gig switch that's being used as the primary data path for that storage that's talking between the nodes in that distributed file system. That converged scale-out storage that you have there is going between the nodes in that 10 gig, but for a given VM that's running, most of the time his active data is on his primary disk tier on the same node that he's running, and he's not even going to the top of rack switch to get his data. But if I destage that data and move it to that secondary tier and stripe it across the whole cluster, whether it's one 4-node block like you see here or several of them that are working together as a cluster, then you're going to see us going and getting that data over that very high bandwidth, low latency 10 gig that's faster than what most people are running for their SAN today, right? And so you've got that's there, and then we have, that's one 10 gig port, and then we fail over if somebody goes up and pulls the cable on that 10 gig, or if they apply a bad switch config, which the mean time between failure kind of statistics on even the human error side of that's about 2%, is it fails over to 1 gig ports that are present on each node as well. So you can get those in our next generation that's already in beta internally that's got 2 10 gig ports on it. But what we find so far over the past year is a lot fewer people are willing or wanting to pay for a second 10 gig port when typically they're only 6% utilized even for VDI except during boot storms to utilize that I/O, right? So you'd be paying for a totally separate 10 gig port, $400 a port, on this side and on the switch side typically for something that's used less than, 5% of the time. Okay? And so that's what it's doing. It's failing over to be able to give you time without crashing the VMs that were using that storage to be able to vMotion, to be able to fix what the problem was, to be able to get things back up and running from that perspective. Okay? So you got 10 gig networking that's doing that between the nodes. It's also the primary data path that you're using for your VMs back to your production network as well. Okay? So that single cable is being used, so 4 per block. And then you've also got what you'd consider to be an ILO port or an iDRAC. It's an IPMI port that's allowing you to do remote power, remote console, things of that nature in the system. Okay? So that's the processors, the memory, the Fusion I/O card, the SATA drive, the disks that we're using in the back end, and the network. Any questions that we can tackle there before we go on? Okay? So we mentioned having the hypervisor pre-installed. And so we do that to make things faster when it comes on site. And literally, when I come out or a partner SE comes out to do the install, literally all they're going to do is change the IP addresses to what's appropriate for your network and start up the storage cluster. And then it's going to take, using those storage VMs that's on every node in the cluster, again, whether it's 4 in one 2U block or customers that have 4 or 8 or 12 of these blocks, each with 4 nodes in them, you're seeing where you can really get a lot of scale. So there's 20 terabytes of storage to go along with that 768 gigs of RAM, along with that 48 cores of processor that you're getting in each 2U.
Quick question, is there any intercapacity like networking if you use one of the ports on one of the nodes, or you use one or just traverse through one of the other NICs on the other box?
Right, so you're asking is inside the same enclosure, inside the same chassis. So the chassis, again, because we're intentionally keeping the costs down, we want you to have the flexibility to use whatever networking you want. There's nothing in that enclosure, that chassis, except power. Okay, so you're getting the redundant power, but everything else is either direct attached, like this blade is physically, plugged in to use just his storage. And then even for this node talking to this node in the same chassis is going to be the same as this node talking to a node in another chassis because it's made for scale out. And I don't even want to get into what you used to see with NUMA and affinity kind of stuff to say, I prefer to talk to this guy instead of having to leave and talk to somebody else. It's made to scale to hundreds of nodes over time. And so we want the same hop. So it's going to be one hop, top of rack, back down, if you're talking between the nodes. And then we're going to take whatever you're talking to over here, say it was a data for this VM's disk, I'm going to move those active blocks up to the tier, to this primary storage tier, and it's going to be running on the same node without even going through the switch.
You might be going to this, but scale out, is there the capability to do stretch clusters to another DR6?
I'll say it's possible, with the same caveats that VMware or anybody else is going to tell you about latency to storage and all of that stuff. It's not something that we've tested a lot because we haven't had demand for it in the same cluster. What people will normally do is says, okay, I've got a cluster here, I want to do DR replication to a cluster somewhere else, and to be able to do that. So the normal latency type of stuff is going to apply in what's the storage getting to, the VM getting to its storage. What's complicating things in our piece is that storage controller VM is actually making that distributed file system and then presenting it back to the hypervisor. So even internally inside of what we're doing, we'd have to take an eye on what those latencies are between those pieces. So for us, it's single switch.
So presuming a higher latency, then again, DR scenario, is there technology here to allow for that asynchronous replication in that case, or do we have to have something sitting on top that will do that?
Right, so you can do the host-based replication today, and then in the third quarter is what it's currently planned for, is it's got the array-to-array replication to be able to go site to site, without, just using VAI from VMware or other types to do array-to-array replication. Okay, so we can talk some more about that from a roadmap perspective. But today, as it ships, you'd use, say, Veeam or VMware's Site Recovery Manager or other types of pieces to help to orchestrate that. So host-based replication from SRM would be another way.
Okay, but SRM requires a synchronous replication technology underneath it, so.
No, not with host-based replication, it does not. So it'll also do a replication agent, you know, similar to what you do with Veeam or some other types of pieces to be able to do. No. So it's not using Veeam. It's all from VMware. It's all part of the SRM package. It's just called host-based replication rather than array-based replication. Okay? So we'll go from there. And that's particularly interesting in our use case because the array and the host is actually the same piece of hardware. You're using CPU cycles from the same CPUs, whichever way that you go. But there's a piece that I want to remove and lower some of the complexity and even some of the requirements to be able to make it where we're just taking care of all of that in our software rather than having to do it from SRM or something. Okay, so that's what we're looking at here. So the hypervisor is pre-installed. You can use that. It's nothing special. It's actually just the plain vanilla install from VMware. You can go download it from their site, reinstall it. There's nothing that we're changing in the guest or in the hypervisor to be able to use our storage. It's all in that controller VM and on each node that's working together to form that distributed file system. Literally, if you took our box and you said, thanks, appreciate it, it's pre-installed, but we've got a Kickstart build that we've been using for ages, I want to use it. Do you mind if I hit this button and just blow it away and recreate it? I say, knock yourself out. The only thing you're going to need isn't it related to us at all. It's just the Mellanox driver for this 10 gig chip. As long as you put that into your little installer, you're done. Okay, so that's really key if you talk to other vendors that says, what do I got to do different? What agents do I have to install in guest OSs? What do I have to do in other pieces to be able to make that work, right? And so that's what you're looking at from what we're doing here with our scale-out storage is making things much less complex. Don't change stuff that people got to keep up with and be able to understand more of that complexity that we're bringing to the table because we're not bringing any. We're just using commodity hardware and then layering on top of it a industry standard hypervisor for now and looking to add others as they gain more market traction and more capability around 64-bit and other types of pieces. And then being able to leverage things like this heat optimized tiering that we're talking about. We're writing to that Fusion IO as the primary tier of storage and then destaging that back to the slower, more affordable, more capacity drives in the back end. I mentioned a use case where we actually will be, actually I was told August 1st, so I guess it's coming up very quickly, able to sell all SSD across the back. You'll be paying more for less capacity, but there are certain use cases where they says, I don't care, it's what I got to have. And that's where we're shipping a bunch of units to places with a lot of sand that they hate having around spinning hard drives. And so for them, they're like, okay, I understand it's more expensive, but I got failure rates that would be through the roof where I use spinning disk. Find a way to do it with the SSD. Okay? And so for us, it's just commodity hardware. Okay, fine. It's faster, it's lower capacity, but it works exactly the same. And so if people are just bound and determined, it says, I want to have that. What your normal answer is, yeah, but you're not going to help your performance much because you're already getting your performance from this tier. But it is something that's available if somebody wants to wind up going down that conversation some more. Okay? So any questions at all about this hardware or what we're doing with it from this perspective down here? Okay? Yes?
I don't know if you're going to cover it going forward, but this is not a system that you could just merge into your already existing environment.
Sure you can. So in the vCenter especially, right.
So you have a system already set up for the stand. You know, is vCenter going to be able to recognize where storage is going
Yeah.
to be?
Right, let's talk about that. So the answer there is it's just DSX. So yeah, absolutely, you merge it into your existing environment and leverage it from that perspective. The only piece that you're going to see that's typically done is that these hosts, let me go ahead and hit the next slide and it'll make a little bit more sense, is what we're doing next. Everything we talked about there was with 4 nodes in a single enclosure, but I said it's built for scale out. You know, the Google's guys weren't looking to say, well, I only need 4 hosts ever, right? What they're saying is I need to start with that as my starter block, and it's great that it has the same performance as when I'm really massively huge, but I need to be able to grow. And so what you're looking at here is 3 of those 2U chassis on a dark screen, that has each one of them 20 terabytes. So you're looking at 60 terabytes of raw disk space that's working like RAID 01 that's then provisioned. So you're going to see about 30 to 45 depending on how much storage you're over provisioning. A lot of times it's 40% that's just sitting there idle, so that's the industry standard number. But even if you took worst case and you say 30 terabytes of usable disk space across 12 ESX hosts in that case, I got 12 Fusion I/O cards, I got 12 storage processors in my array, and you're starting to see where that goes as you scale. That gives you that linear scalable performance as you go. Okay? And so now if you go to 6, which is what you'll see on some of our brochures, or 10, which is what you're going to see in our view reference architecture, let's shift over to that one for just a second. And it's going to go towards answering your question here in just one second. So what you're looking at here is like a 22-page document that is a view reference architecture we did with the VMware guys to say, as we scale, how many desktops are we talking about? What's the configuration? Walk me through exactly what the settings are that you used in the testing that VMware does with their partners, any of them that want to do the reference architecture workload configuration kind of stuff that we did, I guess right at a year ago now, that we're taking through and doing, what is that scale to? So in this particular use case with these, office type applications, your mileage will always vary depending on how much memory and CPU you're putting in each of these guests. But what you're seeing here was 300 VMs per 2U box, or 75 per node, which had, if you do the math on that, 2.5 to 3 gigs of memory, right? 1 vCPU, that kind of stuff. What is normal, in your environment, your numbers might be a little bit different, but 300 on one block, 600 on 2 blocks, 4 blocks, 5 blocks, 10 blocks for 3,000 desktops. 3,000 desktops, 10 blocks, 2 U's each. Let's get there. 20 U of rack space for the compute and the storage, running 3,000 desktops. Your power and your cooling per rack might not fit your data center so much, so you're welcome to spread them around, but you're able to run that in 20 U of rack space, compute and storage, 3,000 VMs. That's what we're talking about with a scale out, but that's not the punchline. What's your difference in the application response time as you grew at any stage of that as you're going through that? What you're seeing on the screen there is less than 0.2 of a second of difference that you see across all of that, right? 0.2 of a second, you can't even tell. You might as well say flat performance as you scale. What does that look like with your existing storage today? You go buy the biggest thing that you can afford out there and you start putting desktops on it. You get really good performance when you start, but say it's got 12 processors or 16 processors. What happens after you get 20 or 50 or 100 VMs on there and you keep scaling as you continue to add desktops? They're sharing those processors, right? And your performance is going to decline just because they're doing that sharing. How is that different in what you see here with 10 blocks is 40 ESX hosts? That's 40 storage processors, because you're adding one with every single ESX host that you bring, and that's what's helping you to be able to do that that's linear scalability as you grow. So that's what we're talking about. And taking it and putting it into your existing infrastructure, it's just 40 more ESX hosts. You're just going to have a cluster in your virtual center that you call Nutanix or cool VDI stuff, whatever you want to name it. And inside there, you've got your hosts with their associated data stores. Those hosts can still use other storage elsewhere in your environment as long as they're network-based, because you don't have a fiber channel port. So iSCSI or NFS, anything else that you have in your environment, you can attach to these same hosts. But it comes with its storage that's usually enough for most of its workloads and to be able to do that. For migration and other types of short-term use stuff, you can actually attach our storage as NFS to your existing hosts to storage vMotion stuff over, to do migrations, but we want to be careful about that latency because you've got Fusion I/O and the other stuff that's going to help you a lot as long as it's on that same host where you have the compute and stuff together. And if you're using your ESX host to connect to our storage over NFS, you're going to be introducing a lot more latency and performance that might not be as good as what you're going to see in ours if it's here. So that's the answer to your question, is typically you're going to run it in the same virtual center as the rest of your VDI, or if you want to chunk it up, you can say these hosts go into my server infrastructure, these hosts go into my VDI, or you can run them as a totally separate environment. It's just ESX. There's nothing that's different. It just happens to have its storage there. If you look at what ESX sees, when you're looking at these, I've got spindles, I got flash, I got all this stuff. How does it see all these different tiers? It doesn't. Okay, it's completely transparent to the hypervisor and to the guest OS. All that the guest sees is his normal virtualized SCSI adapter. It just works faster. All the hypervisor sees is his normal NFS or iSCSI that's talking to our storage controller as his destination address. He thinks it's the array. And that's it. And we're handling all of that other complexity around caching, tiering, fault tolerance, replication, scale out. All those types of pieces are being managed on the back end of what we're doing. Okay, so we're about 10 minutes from being done. So I just want to make sure that we're covering everything that we want to get in front of you here. Let's see if this guy's going to come back up. Here's a picture of the physical hardware. If you come by the booth, we've actually got stuff that you can see in a little bit more detail. But it's physically exactly the same processors that you're running today. They're Westmere today. They're moving over to the Sandy Bridge stuff here in about a quarter. You've got your regular DDR3, low-profile memories that you'd see in blades, things of that nature. You've got your traditional, stuff. It's all exactly the same stuff than the regular servers that you're running today. It just happens to be in a dense form factor without the overhead of the enclosure costs and things of that nature. The challenge that I was having before we even talk about some pricing here is around cost. My HP chassis were costing me upwards of $35,000 before I put my first blade in it. You know why? Why? Networking. The chassis cost, all the other stuff. And that's what Google and what Nutanix now is really trying hard to avoid by just going with simple commodity enclosures and then allowing me to put whatever I want top of rack. It can be Cisco, Juniper, Nexus, Arista is a really good partner that does it a lot lower cost if you wanted to go that route. Other types of pieces to be able to do that top of rack networking. It's just got to be SFP plus, direct attached copper cabling, because that's what comes out of the server, and you're good. And so you have a lot more flexibility, even on the cost side, to be able to make that work, okay? So commodity hardware, this isn't our secret sauce. If you bought this today, you could buy it from about 10 different vendors and build it yourself. Probably cheaper because we've actually got a price in there for what we're doing with that distributed file system. What we're bringing to the table as our secret sauce or our intellectual property is that the distributed file system that sits on top of it that makes all of those other things work. The scale out, the caching, the fault tolerance, the tiering, all that kind of stuff. And we're doing it completely transparently under the covers and providing that to the hypervisor, which is one of the reasons why it's able to move between hypervisors, because we're doing all of that inside the controller VMs working together as a distributed file system. Okay, so just in quick review, you've got your normal fault-tolerant power supplies, but 48 cores per 2U, so 1, 2, 3, 4, 5, you're talking just under 250 cores, if you do the math, on 5 of those guys stacked together. 768 gigs of memory, per 2U, 20 terabytes of raw disk drive space, so that would be 100 terabytes of usable in 10 rack units of space. Right, and then you're using, like RAID 0, 1 thin provision. And then the power draw on each 2U block is between 1,000 and 1,400 watts. Okay, and so that's usually half what you'll see if you go add up your compute and storage today, because they're separate today. When they're combined together, typically the CapEx helps a ton because of the hardware that we're using, but OpEx on power and cooling is a lot lower as well because of drawing a lot less power. A ton of references we can walk you through in different areas, some of them perfectly happy with their whole data center in a single server, a single 2U block, and some that are perfectly happy with many of these things stacked together running, for a lot of it's VDI. So again, it's giving you all of these benefits we're talking about here for the caching, the disk tiering, the fault tolerance, the replication, the scalability, the scale out, is all coming from that Nutanix distributed file system that's doing that value add as we put on top of it. Here's the next piece that I want to almost close with here, is talking about the complexity side a different way. Somebody walk me through what it's like to create and provide new storage to your environment today. Anybody doing, say, Fiber Channel today? No, we don't have that time, right? So you know what it's like. I won't even talk about the handoffs between the teams and what kind of time you have to allow from the handoff to when you get it back. But just the, where you're doing the masking, the LUN, creation, the masking, the presenting to multiple switches, the tracking the worldwide names, going into Virtual Center, creating it, scanning for it, all these other pieces, right? Because it's NFS and because it's integrated where you have the compute and the storage already knowing about each other, already mapped there, you know what I ask you for? It's 20 seconds to create new storage. I got some people in the room that can shake or not, am I right? It's 20 seconds to go in there and say, I'm going to ask you 2 questions. Well, 3 if you count the third one. One is, what do you want to call it, the new data store? What do you want the size to be? And do you want me to go ahead and present it to vCenter on your behalf as NFS storage? If you say yes, 20 seconds, just done. I mean, as soon as you answer those questions, you say create, it says done on our side, and then it says, do you want to create this as NFS on vCenter? And it'll say completed, on each of the hosts, and you're done. Okay, so all of that complexity goes away, and I've got customers that buy this box specifically so that the desktop team is able to do that without having to go through, do I need EMC permissions? Am I going to screw up other stuff that's running on that array? Here's your own box running in your own domain of stuff to worry about that's going to be able to make that happen. So we'll be happy to go into that with a lot more detail with you, but this is a web page. And so you don't even have a thick client that you have to install, let alone several that you have to do with the legacy infrastructure that you're doing today. So the next piece is just saying, we're not saying rip out everything you've got and replace it with this, like you saw, dump your SAN and go with this. What we're saying is for new projects and for things that you're doing ongoing, refresh, other types of stuff, start looking at this new type of technology. You hear a new term being talked about now called this software-defined data center. If you're watching the news over the past week, there was a significant acquisition that VMware made in the software-defined networking space of some people that, oh, by the way, created VMware. Diane Green, Mendel Rosenblum, the guys that started VMware to start with, left VMware with some help and went over to start Nicira and be able to do in the networking space what they did in the hypervisor space. And so you're going to see some wonderful stuff start to come of that. What you see here on the screen we've been talking about all day is software-defined storage. It's been that way for the last 3 years. What you're doing is you're saying, I want to be able to allow this storage layer to be defined in our storage so that physically you could run it on anybody's physical compute and storage. The secret sauce is just in the software that we're writing around it. And you're going to see a lot more coming around that defining market space. And you're going to look back on it in 5 or 10 years to close out exactly the same way that you looked at virtualization 10 years ago. You said, looks interesting, looks like it could be transformative, but the promise of what is possible with software-defined data center is so extreme that you're going to see, I guarantee you, within 2 quarters, every single vendor that you're buying from now showing slides that says how they fit into this. It's like cloud getting redefined again, right? Because what it's going to do on the networking side with Nicira coming into VMware is making it to where today I'm able to do all of this stuff virtually with hardware and with storage and compute, but now I've got to still work with my existing legacy network infrastructure layer. And it's going to make it as flexible and virtualized as what you see with your storage and your compute. If you have some more questions about that, we'll be happy to take it. But in the time that we have today, I just want to highlight again, what you're getting is high performance at any scale. You're getting all of that because of that distributed file system that we're layering on top of that commodity hardware. You've got that capability to start small and grow huge. It will be hundreds and thousands of nodes over time. Today we're capping about 50 nodes, which is bigger than what most people are running in an ESX cluster today, or any other hypervisor. And as those get more capable, as you see more announcements at VMworld and other, you're going to see that. But because we're already fully distributed, coming from that type of architecture, it's used to hundreds and thousands of nodes, you don't have any single point of bottleneck, you don't have any single points of failure, and you're able to see that, not just for your VDI, which is what we're talking about today, but for your regular servers, test dev labs that really like having discrete domains to be able to manage, and DR. I could take a box and just stick it in a remote site and be able to balance to it. Here's the guys today that say that they're doing converged architecture, but in reality they're just putting the same servers and storage that you were buying before in a single rack and sticking a tag on it, right? And what we're doing is actually changing that. It's not just repackaging existing components. It's not that 20 to 30% uplift over what you were already paying that's not solving the problem. It's still got the latencies, it's still got the performance challenges. They're still going to tell you to buy SSD and flash to make it work. What we're doing is actually giving you that in what you first start with and letting you grow as you go to be able to get there over time. Pricing, go back and add up what you're paying today. This is list. You'll usually be about 20 points off for street. And so under $100,000 typically for 4 nodes. Go add up what you're paying. If I told you $35,000 before I've put the first blade in there and I'm paying $60,000 for the storage that goes along with it, you're going to see price points that really start coming in line, and you're going to see more of that.